Hey everyone, got a C programming exam coming up? Then you are in exactly the right place. Today we're going to tackle C structs, and we're going to break down the kinds of questions that always seem to pop up on tests, so you can walk into that exam feeling totally prepared. Look, I get it. Structs can be a real headache, especially when your professor starts throwing pointers and file I/O into the mix. It can feel, well, a little overwhelming. But trust me, we're going to get through this. We'll go through real, exam-style problems step by step, and by the end, you'll have a solid strategy for each one. So here's our game plan for today. We're going to start at level 1, the absolute basics of what a struct even is. Then we'll learn a super useful shortcut with typedef. After that, things get a little trickier. We'll jump into pointers and functions. And for the final boss, we'll put it all together and see how structs and files work hand in hand. This is basically our roadmap to conquering this topic. All right, first things first, we have to build a solid foundation. You can't solve the hard problems if you don't nail the basics, right? So let's get a really clear picture of what a struct is and why it's so incredibly useful. So what is a struct? Honestly, just think of it like your own custom-made container. I mean, imagine you have a student. You could have one variable for their ID, another one for their name, and a third for their GPA. It gets messy fast. A struct lets you bundle all that related stuff, the ID, the name, the GPA, into one single neat package. It's all about keeping related data together. Okay, time for our first classic exam question. I'm about to show you a piece of code. I want you to take a second, maybe even pause and think for a moment and figure out what you think it's going to print. Ready? So here's the code. It's pretty straightforward. We've defined a struct called point. It just holds an x and a y coordinate. Then down in our main function, we create a point variable and we call it p. Now pay close attention to this line right here. p.x equals 10. How are we getting inside that struct to change the value of x? And the answer is 10. The big takeaway here is the dot operator, that little period. Whenever you have a regular struct variable, like our p, you use the dot to get to its members. It's really that simple. Just remember, if it's a variable, use a dot. You know, typing struct point or struct student over and over again can get pretty old, and it makes your code look kind of clunky. So let's look at a pro tip, a keyword called typedef, that's going to make our code so much cleaner and easier to read. Check out this side by side. On the left, the old way, you have to write struct point p1. You always need that struct keyword. But look at the right. When we use typedef, we're basically creating a nickname or an alias. Now, point acts just like a built-in type, like int or char. We can just say point p1. It's a small change, but man, it makes a huge difference in how readable your code is. All right, you know the deal. Time for another exam-style question. This one uses our new friend, typedef. Take a look and see if you can figure out the output. See how much nicer that looks? Just nokta n1, no extra struct keyword needed, all thanks to typedef. After that, though, the logic is exactly what we saw before. We're just accessing a member and printing it out. And the answer is 7. So what's the lesson here? Typedef is just a shortcut. It makes declaring the variable prettier, but it doesn't change the core logic at all. You still use the same old dot operator to get to the data inside. Okay, let's ramp up the difficulty a bit. This is where professors love to trip people up on exams. Pointers and functions. Seriously, if you're going to master structs, you absolutely have to understand how they work with pointers. So let's really dig in here. Here is one of the most important rules you'll learn today. We already know that for a variable, you use a dot. But what if you have a pointer to a struct? Well, you can't use a dot. Instead, you have to use the arrow operator. It's that little dash followed by a greater than sign. Just think of it as saying, hey, follow this pointer to where the struct lives in memory, and then grab me this member. And that brings us to a question that I can almost guarantee you will see on an exam. What happens when we pass a pointer to a struct into a function, and that function changes a value? Does the original value actually change for good? Or is it just temporary? What do you think? Okay, let's trace this code step by step. Down in main, we create our point, p, and we give its x a value of 5. Now, here's the key moment. We call the change value function. But we're not sending p, we're sending and p, the address of p. We're telling the function exactly where p lives in memory. So inside the function, the arrow operator uses that address to go directly to the original p and change its value to 10. So does the value change? Yes, absolutely. The output is 10. This is so important to understand.
When you pass a pointer, you're not making a photocopy of your data and sending it off. You are giving the function the actual house key and address to your data. The function can then go right in and redecorate. The change is permanent because it happened to the original. This is a core concept in C.
So far, everything we've done is temporary. As soon as our program stops, poof, all our data is gone. So how do we make it stick around? We save it to a file. Let's take a quick look at how C handles file I/O. Okay, when you open a file with the fopen function, you have to tell it what you want to do. That's the mode. You can see the common ones here. R is for reading, but the two you really need to drill into your brain for an exam are W for write and A for append. W will completely wipe the file clean before it starts writing. A is much nicer. It just adds your new stuff to the very end of the file. Mixing those two up can be a disaster.
All right, time for the final boss. Let's put everything, and I mean everything, we've learned together. Structs and files. This is where it all comes together. Being able to save your custom data structures to a file and load them back later, that's a cornerstone skill for any real-world programming.
There are 4 key steps to doing this safely. First, you create a file pointer and you try to open the file. Step 2 is non-negotiable. You have to check if that pointer is null. If it is, it means something went wrong and your program will crash if you try to use it. If you're all good, you write your data. And step 4, and I can't stress this enough, you always close the file with fclose. If you don't, you could lose all your data. Okay, let's do a quick lightning round summary. If you're cramming for your exam tonight, this is what you need to remember. 1. Structs bundle related data together. 2. Typedef is your friend for cleaner code. 3. Dot for variables, arrow for pointers. 4. Know your basic file functions, fopen, fprintf, fscanf, and fclose. And 5. The golden rule. Always check if fopen gave you back a null pointer. If you can remember those 5 things, you are in fantastic shape. We have covered a ton of ground today, and seriously, you should feel way more confident about handling exam questions on structs. But I want to leave you with one final thought, a little challenge. We just talked about writing a single struct to a file. But what if you had an array of 100 structs? How would you write all of them to a file efficiently? Think about that. That's the next step on your journey. Thanks for joining me.